G'day chemistry students, in this video we're going to be looking at dot points 7.6.1 and 2 again. This is our final video for the module. We're going to be looking at polymers, that's what we started looking at in the previous video, but in particular our focus is going to be on the different types of polymers and the properties that are associated with them. Let's get into it. So first off, we're going to be looking at some polymers that we need to focus on in this topic. There's a list of about 6 of them that are in the syllabus, 4 addition polymers and 2 condensation polymers. The first addition polymer that we're going to be looking at is polyethane, more commonly known as polyethylene. We saw this in the previous video. The monomer itself is just an ethene molecule. Usually there'd be a double bond here, but in this structure that we see, the double bond's already been broken so that those electrons can be used to make further bonds. In particular, we have 2 different types of polyethane, high density polyethane, as well as low density polyethane. The densities themselves lead to extremely different properties, and that's got to do with the bonding structure that's present. I'll be expanding on that shortly. The other one that you saw last time is Polyvinyl Chloride Pvc, very similar to polyethane, the major difference being that one of the hydrogens is instead substituted for a chlorine. The last 2 addition polymers that we're looking at is PTFE, or polytetrafluoroethylene. For this one, there are no hydrogens present. All of the places where there would usually be hydrogens on a carbon chain instead are substituted for fluorines. The last one here is polystyrene. What we see is that the monomer itself has 3 hydrogens, 2 on one and 1 on the other, but on the final spot, instead of there being a hydrogen or a halogen, we have this ring here. It's a benzene ring, or what's very close to a benzene ring anyway. This ring has 1, 2, 3, 4, 5, 6 carbons present. It also has what we would total to be 3 double bonds on the possible 6 bonds, which reduces the amount of hydrogens that are present on each carbon. We don't have to worry too much about the benzene ring itself and the chemistry that comes with that. What we're going to be really focused on when looking at polystyrene in particular is how the properties of polystyrene are impacted by having such a large functional group bonded to what is a very small monomer. So they're the 4 addition polymers that we're going to be focusing on primarily. The condensation polymers that we're going to be looking at as well, we already saw in the previous video. They'll be polyesters and polyamides, also known as nylon. Now, when we're looking at all of these different types of polymers, we're going to be really focused on what can cause differences in properties between them. Now, the biggest thing that influences the properties of a polymer is branching and the resultant structure that comes from that. So whether or not the structure of the polymer is what we call crystalline or amorphous. Crystalline regions, as the name implies, have a very ordered structure. Generally, what that means is polymers are able to sit over the top of each other and make really nice organized groups of molecules. Whereas something that is amorphous is generally branched. A lot of the time we use the analogy of comparing it to what spaghetti looks like when it's all jumbled together. This kind of structure leads to unorganized areas of polymers. And a lot of the time, this branching and structure of our polymers can end up influencing the flexibility of the plastic, how quickly it softens or melts when it undergoes heat. It will also impact its density, its permeability, and its transparency. Something else that can impact strength and flexibility is the chain length of a polymer. And the functional groups that are a part of the polymer itself can also have an influence on bonding, which then has an influence on properties like strength, flexibility, and melting point. So in particular, for halogens and condensation polymers, the dipoles that are present in the bond will end up having stronger intermolecular forces, which will then have an impact on those factors. For those benzene rings that we saw as well for our polystyrene, the size of the side group, especially for that one, is going to have an impact on strength and flexibility as well, something that we'll look at in detail. We can also look at cross-linking. So we can have branching that's actually a little bit more of a positive influence than what we saw in those amorphous sections. Here we have polymers that are quite crystalline in structure, but with the branches that connect them, that's actually going to increase the strength of the plastic itself and will also have an impact on flexibility and softening and melting point. In class, we're going to be looking at these influences do a little bit of research into each of the different types of polymers and their properties. We'll also focus on how their uses are determined by their properties, and we'll relate it back to a lot of these factors which I've just introduced in the video. Thank you very much, everyone. That brings us to the end of Module 7. As we move into Module 8, I'm going to be looking at lots and lots and lots of different applications of chemistry. So we'll end up broadening our understanding of Modules 1 to 7 by looking at how we can begin to apply ideas to more practical contexts. But until then, have a good one.